Alright, today we're going to be looking at equations where all of a sudden now we have variables like an x on both sides of the equal sign or both sides of the equation. And how do we handle that? So today's notes are about variables on both sides of the equation. So how do we handle this? Well, step one is always going to be simplify both sides. So if there's anything we can simplify on the left side of the equal sign or the right side of the equal sign, we're always going to do that first. Now today's work, there's not really going to be much of that, but we're going to eventually look at ones where the first thing you need to do before you do anything we learned today is simplify. Okay, but next, if you do have a variable on both sides of the equation, you need to eliminate one of them. So eliminate a variable. Okay, and your best choice is always going to be the smaller one. Now, if you eliminate the larger one, you're still going to get it right if you follow all the correct steps. The problem is when you eliminate a larger variable, you create negatives. And where do we make the most mistakes is with negative numbers. So if we always eliminate the smaller variable, we ensure that we're going to have positive numbers, and we're just going to make less mistakes. And then number 3, solve. So once you've eliminated on both sides, you're going to solve. So if I take a look at number 1, I have a left side and a right side. So for just this problem, I'm going to put the dotted line down there to make sure we're looking at the left side and the right side. And I need to simplify both sides. So if I look at the left, x plus 3, there's nothing there to simplify because x and 3 can't go together. And if I have an 8 plus 2x, nothing that I can do with those two. Okay, they cannot be combined. So these are already simplified. So step 1's already done. I can't do anything to simplify these any more than they already are. So step 2 now is going to be to eliminate a variable. So we've never had an x on both sides of the equation. So we want to eliminate one of them, get rid of them, and then as soon as one of them's gone, it looks just like the kinds of problems that we're used to. And then we just solve like normal. So we're going to eliminate the smaller variable. That's the ideal situation. So if I have an x and I have a 2x, the smaller would be the x. So I want it to basically just go away. So how do I make an x go away? How do I make it go to 0? Think about it. How do I make an x go to 0? I would minus x from it. So if I do x minus x, I have 0. And it's gone. Now, am I allowed to just do that? No. I always have to keep this equation balanced or equal on both sides. So I can do anything I want from this side. I can minus 3 from this side if I really wanted to. But if I do that, I have to minus 3 on this side. So if I'm minusing x on this side, I need to minus x on this side. Let's see what happens. X minus x is 0. We don't have to write it. It's gone. So if you want to cross it out, you can cross it out. The only thing left over is 3. On this side, notice how I wrote the x directly under the 2x because that's where it's going to interact. So the 8 is going to kind of still just be left alone. And a 2x minus a 1x is just x. So this is like 2 minus 1. So my answer is a 1x. It's a positive, so I'm going to put a plus. 1x. And if you put the 1 in front of it, perfectly fine. I'm just going to put x. So these two equations are equivalent. They mean the same thing. Okay, but I've eliminated an x from both sides. So 1x went away from here and 1x went away from here. So now there's none over here and there's 1 left on this side. And now it's a pretty simple equation to solve. Our final goal is always to get an x by itself. So right now I've got the x over here. If I want to get rid of this 8, I'm going to minus 8. And this will give me my final answer. The 8's go away. 3 minus 8 is negative 5. So you can just believe me and say, okay, that's how you do it. Or we can check it and make sure that this answer actually is correct. So let's run a check. Rewrite the original and plug in negative 5 for your x. So negative 5 plus 3 equals 8 plus 2 times negative 5. Now, we've never looked at checks where there's things going on both sides. So just a reminder, we're not going to start subtracting from both sides and adding to both sides. That's only what's things that we do when we're trying to get a variable by itself. There's no variables in a check, right? All the numbers are here. We're just going to simplify the left side and the right side. So for just this one, I'm going to put that line down the middle again. And we're just going to work on this side, and we're just going to work on this side and see if they can come out equal to each other. So on the left, -5 plus 3, that's -2. That needs to be equal to this side. Now this side is going to take more than one step. So step 1 is going to be multiply. Follow your order of operations. So I'm going to leave the 8 alone. So 2 times -5 is -10. So it's going to say 8 plus -10. So it's going to be another line. So this -2 now can just drop down. And 8 plus -10 is -2. Both sides come out equal. My check is good. That means my answer of -5 is correct. So simplify the left all the way down to a single number. Simplify the right all the way down to a single number. If they're the same answer on both sides, then we know we got the check right. All right, let's look at number 2. So number 2, I see fully simplified left side, fully simplified right side. But I have an x on both sides, which I don't want. So I want to get rid of one of them. The smaller one is the one that I want to get rid of. So I can take an x away from both sides of the equation, and I'm good to go. So if I minus x and minus x, I'm going to get a 6x, 7 minus 1. Bring down the minus 13. Bring down the positive 5. This x is gone. I took an x away from it, so I'm at 0. Now I have a two-step equation. Simple to solve. Get x by itself, so add 13. These cancel. Divide by 6. And x equals 3. So let's try the check. Rewrite the original equation. Everywhere you see an x, put a 3. So 7 times 3 minus 13. It needs to equal 3 instead of x plus 5. So right away I see that right side is going to be 8. So I need to make sure that this other side also comes out to 8 for this check to work. So one step at a time. 7 times 3 is 21. Bring down the 13. Once you're down to a single number, it's going to continue down this right side. 21 minus 13 is 8. We're good. So my answer of 3 is correct. So 7 times 3 minus 13 is the same as 3 plus 5. They are equal to each other. Plug any other number in there and it is not going to be true. 3 is the only correct answer. All right, so let's try number 3. The first two, you notice, I had just a plain x and a plain x, and that's what I got rid of first. So here on number 3 now, I don't have any plain x's, or in this case, they're k's, but each one has a coefficient of something other than 1. So my goal is still the same here. I need to get rid of one of them. There's no simplifying I can do. I'm not allowed to simplify across the equal sign, so I can't put the 6k and the 2k together and call it 8k. If they were on the same side of the equal sign, then yes. But they're on separate sides. This is an expression. This is an expression. They're separate. Okay, I can't combine them. So I need to not cross over that imaginary line. That is the equal sign. So I want to get rid of one of them. You can get rid of the 6k or you can get rid of the 2k and you can still get it right either way. But if I minus the 6k, it would go away here. But when I minus the 6k from 2, I'd get a negative 4k. Now, is that a problem? Not necessarily. But when I have negatives, more than likely, that's where I'm going to make a mistake. So if I choose to get rid of the 2k instead of the 6, that's going to produce a positive number, and I'm less likely to make a mistake. So I'm going to recommend that you always get rid of the smaller of the two variables. So if this is a 6 and this is a 2, we are going to minus the 2k away from both sides. So you can always take the same amount of variables from both sides. I'm going to take 2k away from this side, and so I'm left with 0k. There's no k's left over, so I still have just a positive 1. And on this side, I had 6k's, and I'm going to minus 2k, so I'm left with 4k. And then don't forget about this guy. We still have a 1 over here. So the k's have been eliminated from the right side. 2 of them got eliminated from the left side. Now I'm good to go. So I want to get k by itself. It should say k equals my answer eventually here. So I need to minus 1 from both sides. When I minus 1 here, it cancels because it became a 0. I don't need to write it. I still have a 4k on that side. Now when I do 1 minus 1 here, you could say that it cancels. It gets me 0. But I need to write something on this side of the equal sign. So when I got 0 on this side, I didn't have to write it. Plus 0 is not necessary. But on this side of the equal sign, there's nothing here. So I do need to put something. So 1 minus 1 is 0. So if it's going to hold this whole side of the equal sign, that place, you need to put the actual number 0. Technically now I'm going to divide by 4, even though you should think about it. 4 times what is 0? Answer is going to be 0. So 4 divided by 4 gives me a 1k. 0 divided by 4 is 0. So k equals 0. 0 is an acceptable answer. Let's try the check. 1 plus 6 times 0 equals 1 plus 2 times 0. So both of these sides have some simplifying to do. So 6 times 0 is 0, so it's 1 plus 0 on that side. 2 times 0 is 0, so it's 1 plus 0 on that side. We end up with 1 equals 1. Our check is good. All right, now let's go to number 4. Here's where it can get a little tricky. We've got more minus signs, which are negative signs. So we need to eliminate one of these two variables. We can't put them together because here's my equal sign, here's my dividing line. Okay, they're not on the same side. I can't put them together, so one of them's got to go. Now, which one's smaller? Think about it. -4 or -3? Which one's actually smaller? -4 is smaller. So that's the one I want to attack. Now, we've minused. You need to be careful. Why did we minus? Because that got me to 0. 2 minus 2 was 0. So I need to get a -4 to 0. I don't minus 4 to get to 0 from -4. I add 4. That's how I get to 0. -4 plus 4. So I'm going to add 4n to both sides. All right, little tricky. This is the smaller of the two, and it's negative. So to get a negative to 0, I need to add. So these go away. I'm left with just a 1 equals -3 plus 4 is +1. So it's just n minus 4. Almost done. N's almost by itself. Just got to get rid of this -4. So once again, negative, I got to add 4. These go away, and n equals 5. Let's try the check. 1 minus 4 times 5 equals -3 times 5 minus 4. Let's see if that's true. One step at a time on each side. So first multiply. So it's 1 minus 20. Over here it's -15 minus 4. So 1 minus 20 is -19. 15 minus 4, -15 minus 4 is -19. It's good. All right. I want you to pause the video and I want you to try 5 and 6. So pause the video, try 5 and 6. If you want to show a check, show a check. You don't have to show a check on these. I just want to see if you can get them right. You can always show a check to check your answer. But I'll put these up in a second, so pause the video. So if you go check number 5 now, you should have already tried this one. It's a little tricky because we've got an n and a minus n, and you got to say, well, which one of those is smaller? Well, it's a 1 and a -1. So -1 is smaller. To get -1 to 0, you have to add 1n. So we're going to plus n to both sides. That eliminated here. Be careful. A lot of people will think all of a sudden now it's going to eliminate here, but it's an n plus an n. That's a 2n. From there, it's fairly straightforward, and I even did the check. All right, if you haven't done number 6 yet, pause the video again, try number 6, and then I'll go over that one. So number 6, when I realized I had variables on both sides, I was comparing a 7k to a -6k. So if you're comparing two variables and one's positive, one's negative, the negative is always the smaller one, so that's the one I want to eliminate. So to get rid of a -6 or a -6, to get it to 0, I have to do the opposite, add 6. So -6 plus 6, that cancels. So it's going to be a 7 plus a 6 to get me 13k. -3 comes down, 10 comes down. Now it's just a 2-step. Plus 3 on both sides, divide on both sides, I get 1. And then you can run your check, and sure enough, it's there. So if you missed any of this, you need to fix any of this, copy this down. And once you're all set with this, classwork's on the opposite side. Give that a shot.